Hello and welcome. Good morning, good evening, good afternoon, and welcome to the first episode or first installment, I guess, of this year's training series run from the Neo4j Developer Relations team. I'm Alexander, and I'm very happy to have you here, Michael. Welcome.
Hello, Alex. Good to see you.
Good
Always
to
great
see you
to
all.
see you.
Thank you for joining, Michael, and for guiding us through today. So, as I said, this is the first episode. So we do this from today on every Wednesday with a short break for beginning of April due to Easter. But this week intro, next week intermediate Cypher, week after geospatial, and we finish it off on the 12th of April with Spring Data Neo4j. So it would be great to see you on this journey. Come along. You need to register for each episode if you wanna join it on. So I will post a link into the slide, into the chat in a little bit. But yeah, I guess we're almost ready to go. I'd like to say a few words about technicalities before we start. So it is live, obviously. So if you have any question, if you see anything you want to know more about, please use the Q&A function for your questions. Our lovely colleagues Elaine and Will are in chat and will answer questions as they come in. As well as I will read out a couple of times questions publicly. So Michael, whenever there is a few moments, we can answer them on stage, I would say.
Yep.
But exactly. If you have anything
let's make this lively. Ask all your questions.
Exactly. Make it interactive. That's always fun. If you watch this on the restream part out on YouTube or LinkedIn, then be aware that we might not be able to answer all your questions there. If you want to make sure your questions are answered, the Big Marker stream is the place to be. I see people from Nevada, from Poland, from Romania, from the Netherlands, Canada.
Share where you're watching from.
Exactly.
That's really interesting to see.
New Hampshire and the UK. And we are from Germany, Michael and I. So I guess it's a truly
sunny Germany here. Sun is shining outside.
Not really here.
Not for us, it's really bright. It's like spring has arrived.
That's good. Good. At least on your part of the country, it has arrived. Here, it has not. I can tell you, it's super cold. It snowed overnight. So, well, everybody what he deserves, I guess. Right. With that, exactly, not in Munich. Somebody else is in Munich here. The spring has not arrived. But yeah, the session is recorded, so if you cannot watch it to the end, there will be a link I will send out to you afterwards if you miss out anything. And the slides that Michael will be presenting off, we will also share with you, so you will be able to catch up on everything afterwards. So exactly. That's the case, and I think with that we are ready to go.
Ready to go, ready to roll. Are you all ready? So, thanks a lot, everyone, for joining. This will be an about 2-hour session. We'll have a short break in the middle, so you can have a bio break and grab a cup of coffee or tea, and then come back or ask your questions. And we'll be using Neo4j Aura DB, which is our cloud service, so you can all code along. That's actually what I want you to do. So this is meant to be really interactive and hands-on. So in the beginning, a little bit of an introduction, but we'll go into the details pretty quick, right? So I hope all of you are new to Neo4j and new to graphs. If not, this might be a repeat for you, but we show also some cool new features as well. So even for you, it should be nice. Otherwise, as Alex said, we have more sessions coming starting next week for folks that are already a little bit familiar with Neo4j and graphs. So we start at the beginning with why graphs, why are they cool, looking at some graph scenarios, and then going into Neo4j and getting our hands dirty. Actually, I decided this morning to redo the whole training, and so we'll see something that's really fresh and we haven't done before. And let's see how good my editing skills were. I hope I didn't miss anything in terms of updating. So many of you already added yourself on AuraDB. So if you come haven't done that yet, you can still do it right now. So we do it at the beginning so that the database can be provisioned behind the scenes. And we might need to delete your old one. So let's see how that goes. Join me, go to console.neo4j.io. If you haven't registered yet, register quickly. You might need to verify your email and then log in to that, and then we'll take it from here. So I'll just go over here. Let me log out really quick so that you see what this looks like. Log out. Does it log out? Yeah. So this is console.neo4j.io login screen, explains a little bit what Aura is, and you can sign in with your email address or password. I'll just continue with my Google account, and then I'm logged in. And for you, it might be directly going to the new database screen, this one here, or not. If you have already a database, you might need to delete it. So I can, for instance, show you what this looks like. I have a bunch of instances from our live streams running. So we could basically say, if you want to delete a database, you just click the delete button, and then you have to type in the name, and then you can basically click on destroy, which you should probably do if you already created one, so that we start all at the same. Or if you have created actually the start here database, then you can also keep it and we take it from there as such. So what I want you to do is pick this start here database to start with, and then click on create. So this shows up a pop-up with the password, which you can copy to your clipboard, but it's much easier to just download the end file. The end file is basically an properties file that you can have a look at, which has connection URL, username, password, and instance name in there. And we need to say, I confirm I have copied this. And then it basically goes ahead and creates this instance. You see this kind of spinning here. So it's called instance 01. I can say rename this instance to training. And while it's starting up, we can look at the end file really quickly. Let's have a look at this, and let me show you. Basically, it's here in my VS Code, as you might not be able, might be able to see. I just have to close this Finder window. So you have a Neo4j URI, Neo4j username, Neo4j password, or instance name in here. And basically, most of the time, we just need a password. At the end, we might also need the Neo4j URI. So just to show you what's in this end file that you downloaded. Of course, your password and your instance URL will be different from this one. Cool. And while this is being set up in the background, we go back to our overview and see where graphs are cool. So this is kind of just repeating what we've done so far. And then we go into this. So what is a graph? So in the English language, people mix up graphs and charts. So we have the typical question, okay, this is a chart, this is a graph. So we're talking about the left thing here, right? So a network of entities and their relationships, or network diagram, things like that. So basically, graph is a set of entities which have relationships with each other. And it originates from Leonhard Euler in Königsberg or in Kaliningrad with the 7 bridges problem, which he took and turned basically the geographic problem into a graph problem by turning the bridges into relationships and the landmasses into nodes. So it basically looks like this. And the question was, can we cross every bridge exactly once, basically, and get through, still get across all the bridges? And this doesn't work because some of these nodes have 3, actually most of them have actually 3 entrances. So you can basically get there, leave, get there again, but then not leave again, so you can't exit. So it was actually pretty easy for him to say, no, we can't do this. But that was kind of the origin story of graph theory. And then many of you might have seen it at university or ignored it. So I actually skipped it at university, I think. I actually don't remember attending these courses. But fortunately, graph databases are not so much about graph theory. Fortunately, graph databases come much more from a pragmatic application development. How can I represent my domain nicely as my domain model nicely in a database? And for all of you that have ever tried to store complex connected domains in a relation database, know that join tables rule supreme, and you oftentimes don't see the forest for the joins in your SQL statements. So that's what also where Neo4j and graph databases came from. Kind of the difficulty storing kind of challenging or more complex domain models in a relation database and querying them efficiently was what led to the creation of graph databases. And that's what we're gonna look into a little bit. So anything can be a graph. You probably have examples. You have your family, your work connections. If you look at markets and their connections, at last weekend we saw Silicon Valley Bank going up in flames, but that was basically all the people that pulled their deposits, right? So they basically, the bank is dependent on their customers not pulling all at the same time at their deposits, and that was because of some of the assets were at risk and things like that. So you have markets, you have the internet, you have applications running on the internet, people being connected in social networks, in professional networks, and so on. So everything can be a graph, right? Everything from a simple molecule or complex molecule, look at our DNA, or other more complex proteins and other molecules. The internet, if you have ever looked at the ISO-OC stack with the 7 levels, every level is basically a different kind of network that has different kinds of connections, all the way up to the top where the apps are then connecting people, for instance, right? So you can look into arts, you can look into sciences, in history, in politics, geography, and all the other places. So basically, there's no such thing as disconnected information out there, right? So every piece of information is connected to something else, and everything together forms a gigantic graph of data. Why are they cool? Here's a quick example of like a trainer purchase. So my kids usually, or at least my youngest daughter, likes to buy trainers. And here is an example of a bunch of people in a social network. They basically bought trainers at different dates. But why did they do it, right? So this kind of more like a dependency question. So one person started with buying the trainers and tweeted about it. So today they would probably post it on Mastodon and not on Twitter anymore. But they posted a message on a social network. Another person read it, and then basically based on this message, Alison knew Jane, and she trusted Jane that this is a really cool pair of trainers, and so she went ahead and bought one again. So capitalism is happy here, people buying more stuff. We should probably change this example to something more, for future proof than this. And then basically she posts on another social network that many young people have not heard about. It used to be called Facebook. My trainers are brilliant. So Ian reads this and also goes ahead and buys another pair of trainers as such. So you basically see there's several networks overlaying here. It's basically the purchasing network. That's also something that we'll look into today. But there are also the social networks and the connections in the social network that kind of form a fabric of modern society, right? And so that's quite interesting. And imagine you have to represent all of this in a relation database. There's a lot of join tables that will make the rounds, right? At least for each of these relationships, there are at least either there's a foreign key or there's at least a join table in the middle that connects the entities like messages and people, or people and products as well, right? And so you can imagine like running an query on this network has a lot of joins. So, and then Ian, of course, also posts on Instagram. Not on Insta. I learned that we should not say Insta because that's what old people say. It's called Instagram, right? So, of course, there are lots of different applications. And if you go to the Neo4j website, there are lots of examples of use cases, customers, and so on. And one that's especially close to my heart, I actually wonder if I have the book here somewhere, is Panama Papers and Paradise Papers. So the ICIJ, which is a journalist organization, basically got data leaks from shell companies, and they used a graph to take this leaked information to pull together the information and then allow journalists actually to connect the dots and write their stories and find starting points for investigations. And this is the domain model. Actually, it was much more complicated. If you want to try this yourself, there's also an implementation on Neo4j Sandbox, or we have also written a number of blog posts about this. And we're also collaborating with the ICIJ going forward. Actually, I have a meeting with them tomorrow, which I'm really looking forward to, of integrating Neo4j close into their stack. And so that's one example, but also, as I already mentioned, social networks, core actors, any kind of consumer network, be it something like a music platform, video platforms, all these kind of things where you either buy or listen or watch something, and then you comment and rate it, and then other people get recommendations from that. These are typical graph network as well. So let's look at a bunch of scenarios that make sense for graphs. So one is, does our problem involve relationships between entities, right? So we need to understand these relationships. And as I said in the beginning, we don't really have disconnected information that's not, in some way related, right? So this is kind of more or less the graph that we're looking at later today, which is kind of a retail graph. So we have categories, products, customers, and you could apply the same to an app store, to a video platform, or similar things, right? So we have categories, we have tags, things like that, products, and then people interacting with them. That's kind of the transactional information that kind of view or purchase or things like that. And from this kind of data, then we can basically do really interesting things, right? So we can write recommendation queries for people that look at kind of who's their peer group, who has a similar behavior than the current person. We can also look at fraud. We can look at like payment patterns of people and see when certain patterns occur that usually prevent fraud. We can actually interject and basically deny payments and things like that. But we can also see kind of what are popular products. Can we do something with promotions there? And so on. And as we've seen with the trainer network, if you overlay this with other networks like social networks, then you can also use that for either for promotion or finding trends or things like that as well. Another one is organizational hierarchy. So usually trees are an subset of graphs. So we have a lot of trees in our world, right? So we have basically not just the trees in forest, but also trees that form category hierarchies. We have lots of companies that have deep employment hierarchies. We have, but also, for instance, in software, we have, each program is an AST, which is a tree, or each project has, sub-packages, folders with files in them. So that's another tree that we can look at. But also, if you look at, for instance, memory of your application forms also a tree that's in garbage collected, and many others as well. And kind of operating on these deep trees is also something that graphs are really good at. And so that's another really interesting use case. Another one is kind of, are there deep relationships where we don't know how deep they are, right? So if you have like a more complex thing, looking at supply chains, for instance, which is more visible these days. We've all been involved in supply chain shortages in the last few years, where certain things from face masks, like this one, or computer chips to bike parts and other things have been in short supply. And how do you manage risk in your supply chain, right? How do you kind of figure out, are my suppliers at risk, and kind of, or even my second or third degree suppliers, which then impact my suppliers or my second degree suppliers. The same is true for sustainability or greenhouse gas emissions, right? So if I want to make sure that I have only sustainable suppliers, then I have to do this over multiple steps, but I don't know, is this like a scope 2, scope 3 supply chain? And the same is true with greenhouse gas emissions. So if I want to make sure that my company is kind of certified and verified for being carbon neutral, then I also need to make sure that my suppliers are the same as well, right? Another one is routing here. I think we have another example for that. This one, logistic infrastructure routing, where you have train and car networks, you have logistics, you have multimodal transport, things like that. But similar to that, you have computer networks. Look at basically your cloud deployments, which services depend on which other services, what happens with this one service or this one egress point goes down. Do we have alternative routes, for instance, right? Or if you look at software supply chain things like dependency management, what happens when one of your libraries has an CVE, how quickly can you figure out which of your software packages is affected by that? or the other way around. If you have a software package that you want to upgrade, which applications do you need to upgrade in your company as well? So dependencies and especially multi-level dependencies where you don't know, is this kind of 2 steps away, or is it 5 or 10 or 20 steps away? That's also a really good graph problem. Cool. So much on use cases. If you have more questions on that, you can always go to neo4j.com/use cases, and you find a lot of material there on all the different use cases, including case studies, companies, and so on. So there are like 15 use cases, which is also interesting, right? So because Neo4j as a general purpose database is also very versatile. So you can use it in every place where you could use a relational database. Plus, you get all the graph power on top of that, right? So I oftentimes say kind of graph databases are like the next generation of relational databases. It brings along all the good parts like transactions, data safety and security, query language, rich domain modeling, ad hoc queries, and so on. Plus you get all the other graph benefits on top of that. Okay, speaking of data models, so if you want to look at a property graph model, what does it look like? Right? What are the constituent parts of a graph data model? So first of all, we have our elements, which are our entities. We call them nodes in the scientific literature. They're often called vertices. These are basically the elements in our graph, right? So you might have seen that if you draw something on a whiteboard when you discuss with a friend or colleague, then you would basically start drawing circles and put information into the circle. So in this case, we have here Jane and her bike as 2 entities as such, but we don't have much other information on these, right? So they're currently disconnected there, so they're kind of lonely nodes without any connections, which is not really what the world looks like. So let's see what we can do to that. So a real graph comes into play when we add relationships to that, right? I mean, a single node is also a graph with 0 relationships, but we want to have basically connected nodes. So we add directed relationships to that, which also have a name or a type as such. So that's at least in Neo4j relationships always have a type and a direction. And relationships have always a start and end point. So there are no 404s or broken links or lingering pointers as such in a graph database. Basically, that's the only and core integrity rule of a graph database. So if you don't add any additional constraints or so, that's the integrity rule every relationship has in start and end point, right? And so you can have a node without relationships, but not a relationship without nodes. Right. So that also means when I delete a node, I need to make sure that I also get rid of the relationships, because you can't have dangling relationships that are hanging around. And then the other thing, because it's a property graph database, we add some more things. So one is on nodes, we can add so-called labels. You can imagine labels is something like a role, so you can use them for different purposes. So one purpose is to define a type of something. Like here in our case, you have person and bike basically as a type. But I see them more as something like a tag or a role, right? So a person can have multiple roles, and an item can have different roles in different contexts. So you can use them for type, but also for other things like classification, status, and other things as well. So in our case, we have, for instance, here the example, a bike is also a vehicle. So Neo4j itself doesn't manage any inheritance hierarchies or something like that. We treat them more as composites, basically, right? So you basically can have, multiple labels on the same node, and they kind of form different aspects of that entity in some way. Cool. And then why is this a property graph database? Because you can add properties both to nodes and relationships. And those properties can be, strings, numbers, booleans, or arrays thereof, not nested documents or complex data structures as such, at least right now. And those can be stored both on nodes and relationships, but you don't need to store nulls. So a graph database, or most graph databases, are not schema based. So we have an optional schema. So you can, if you want, express the requirement for certain properties or certain property existence. But by default, the graph database doesn't care. You can have as many or as few properties on a node or relationship as you want. Properties on a node are usually what you have on an entity in your domain, and properties on relationships are oftentimes something that qualifies the relationship, something like time or distance or weight or things like that. Confidence, for instance, is another good property for a relationship as well. So we don't need to store nulls because it's schema free. So if you don't have information, or if you just have a default values like an empty string or something like that, rather don't store it and reconstitute it when you read it in your client or in your query. That also saves you a bunch of storage space as well. Cool. So much for the property graph database. Are there any questions right now before we go into the actual exploration as such?
There's one question we potentially could look into. What's came up? What's the difference, or what is the main difference or the differentiator between Neo4j and other databases? Is Neo4j, would you say, more efficient in contrast to, or in comparison to, let's say, Postgres or something like that, or is it just more effective, or is it depends kind of question?
Of course, it depends question, right? So because it really depends on what the use case looks like and what you do. There are a lot of times when a graph database is as efficient as a relation database. There are certain times. So, for instance, if you just look at data warehousing or analytics databases, then a graph database is not kind of the equivalent of that. You would also not store like binary data or videos or movies or files into a graph database. But every time your domain is complex or interesting, that you have like entities with a number of connections, then looking at a graph is actually quite interesting, because besides kind of storing and retrieving them with queries, what it also opens up is several other possibilities. You can basically add multiple overlaying graphs to your domain, so you can fetch data from other information sources and add it to it. Then you can also compute either directly on the graph data or on projected data, things like do my entities in my graph form clusters? Can I compute recommendations and so on? We have a bunch of use cases on the website where, for instance, for creative social networks, like large Cassandra cluster was replaced by 3 or 5 Neo4j instances, because it was more of this kind of social network use case, right? So it was not basically something that Cassandra as a column store is basically great at, like arbitrary queries of arbitrary depth with a lot of joins, actually, right? So in Cassandra, at least. We have some other use cases where it was more on the analytics side, where people had to follow really complex relationships that they couldn't do with other databases as well. So it really depends, and I also recommend you to basically take your data. You can follow what you've done, what we're doing today, but if you also want to kind of input larger volumes of data, we also have like bulk importers and things like that. Put your own data in, look at like what it looks like, run some queries and see what kind of benefits would the graph bring for you. Also, if you want to do like benchmarks and so on, do them best with your own data and don't trust someone else's benchmarks, because they're always tuned to the publisher of the benchmark. Right?
Yeah,
Exactly.
And I think the other question that came in a couple of times now is the differences between labels and relationships nodes and relationships, and when to use what, and when something should be a property or what. I guess we go into that a little bit later. So
we go into it a little bit later, but we also have a really good modeling course on Graph Academy. So if you go to graphacademy.neo4j.com, we have a lot of courses there, including graph data modeling as well. So that goes more in depth on those topics as well.
That's a good point.
Again, it's one of those it depends questions as well, right? So sometimes, for instance, here in our domain that we're looking at, or actually, let's look at this a little bit later when we look at modeling a little bit, and then we can discuss this a little bit more. Right? Cool. So our domain today is something that's actually familiar. It has been around for a long time, this Neo4j dataset. We picked it because it's quite familiar for people, and it's actually quite nice to see how all these kind of join tables basically can become relationships in a graph. So basically, if you look at the difference between the relation model and the graph model, you see that many of these kind of join tables turn into relationships as such. And you also can get rid of many of these additional IDs that you have to store in your graph as well, right? So because these IDs are basically represented by the natural relationships between entities as such. So this is a retail data set. And as I already mentioned, this kind of pattern of retail, meaning we have users, we have some kind of item. So for instance, in our case, the item is the product. These items can be then in categories or tagged or whatever you want to do. And then the user somehow interacts with this item, right? So they purchase a product, they watch a movie, they listen to a song, they install an app, they rate a movie, you name it, right? So something. So this transactional information is really interesting because that's basically the purchase aspect, right? So in a retail graph, it's an order, but in many of the other graphs that I mentioned, it's basically just some kind of interaction with the item. And that's what we then can do, for instance, to build recommendation queries and other things as well on top of that. And that's why it's so interesting, because you can apply the same model to many other different domains as such. And what we want to do a little bit here is basically want to look at modeling the data, importing the data, exploring the data, querying the data, and then building a small API on top of this data today. So that's a lot of stuff. And we have roughly not even 90 minutes left. So let's get to it. So if you have opened or created your database, it should now be running. If you want to, you can rename it, as I said here, with the 3 dots to training. If you're still in the instances view, it has this little, now I have to find it. It has this little tile that you can click on, and then it opens this view. So it's currently empty, and we'll put some data in. You also see we have some code examples here for different languages and drivers as well. And there are some other things like you can import databases, take snapshots, and so on. So we are all starting here. And what we want to do is we click on this open button. And this open button opens Neo4j Workspace, which is our new go-to app for folks starting out with Neo4j, but for everyone else as well. And so I go back. If you remember, I have this end file that I downloaded, and I just copy the password from there and paste it into this one. And then it should connect to my database. Let's see. So it did this. And for you, I think it should open here, and then it should also open here. So we basically go to the import tab, and I clear this out real quick. Yes. And it should also open this getting started guide. So if it doesn't, you can click on this little button, this question mark button here, and it should show you the guides and this getting started guide, and then you can click on it. But in general, it should do this. If not, let Will and Elaine know, and they can help you as such. So these getting started guides are actually quite nice because they kind of walk you through the model. So a little bit of what we talked about, basically what is a graph database, what is a graph, what are the entities in such a graph. You can pop out these images to look at them in more detail, talk a little bit about schema free and the things that you already mentioned as such, which is nice. And then it goes into import and querying and so on. So we kind of follow this guide, but we'll do our own thing, right? So what I want to start with is, if you just want to basically work with your own data and not with the thing in the guide, what you can do is in this data importer panel here, we can map or model our graph, right? So please come along and join me in our journey into graphs. So I clicked on this add node button, and I can basically double click on this circle that popped up here and put in product. You could also use this field up here to edit this as well. And this is our first little node that we have here. And if you want to, we could add a property here and say this property is not property one, but product name, for instance, and it's a string, right? So basically, this is kind of our first entity that we modeled as such. And then our second entity that we can model here is a category. So this time I actually go into this field and type category here. So you see I can do it on both sides, and our property would be something like, let's say, category name, right? And this is basically how you could model a graph. You might have not seen it. So if you hover over one of these nodes, you get this kind of boundary and this plus. The cursor changes to the plus icon, and you can basically drag out relationships into a new node, right? And if you have an existing node, so imagine I delete this again and I add an extra node that's hovering over here somewhere, I can also drag out this relationship and just connect it to this node, and then it connects there as well, right? So this is something that's quite nice and quick. It also has really nice like alignment and other things as well. But for the time being, we just have our product and category. And I can also double click on this relationship and then either enter the relationship type over here and say, for instance, part of, or I can also edit it here, and then it basically can write my relationships here. Right. I can also add properties to relationships. So for instance, imagine I had the information since when this property was, this product was part of this category, and then we could say this is a date time, for instance, or something like that. Right? Cool. So much for the graph modeling bit. So of course, in real domain, as you can see here, we would have other things like order, supplier, customer, shipper, employees that sold the order, and lots of other things, right? So that's basically how you could model your graph, even if you don't have any data available, or if you have just a problem that you want to solve, or you have a colleague that you want to discuss something with, then you can even use this to model your data as well, right? So, or if you want to model something else, you can do this too, right? So these are currently all the lines are just dotted lines. That's because we haven't selected ID fields for our entity. So if I pick product name here and product category name here, they have an ID, and then I also would have to add a file mapping as such. Because adding this file mapping is a little bit more involved, the guide here comes with an automatic mapping, and I think it's probably easiest if we go this route, and then we can progress into graph querying and other things. So we don't need to spend like all our time dragging and mapping nodes and relationships. So I just clear this out. I think it will also override otherwise. So if we go into our, continue with our guide here to page number 5, I think, 4, sorry, step 4 of 11. You have this button up here that says get the Northwind dataset on top of the relational ERD model. Right? And if I click this button, it will actually fetch the data, and I don't have to do anything anymore, right? So it's basically, it's my auto import of our model and our data. So what do we have here? We see basically what we've drawn before is product and part of is kind of this part of the data model. But as you can see, there's much more to this data model. We have a supplier, we have the order here, we have the customer who purchased an order, we have a shipper who ships the order, an employee who sold the order, reporting relationships. You already see that this kind of graph already mixes different graphs like the employee hierarchy together with the supplier and shipper information, plus the customer and order information as well, right? And the product and product categories as well. And then the employees are in a certain territory, which is in a certain region as well. So that's kind of our graph model. This would also be something that you would draw on a whiteboard when you discuss just this information with someone, right? And our data that we're importing here is basically also CSV data. So it's basically relational data. So I can, for instance, pick this one is products CSV, And you see that these are product ID, product name, supplier ID, category ID, and so on. And these are now mapped to our entities on the screen. That's why they also don't have dotted lines anymore, but they are like solid lines. And if I click on this product, I can see that these are all mapped from the file. So you can basically do something like select from file, and then you can basically select which properties should be mapped from this file. And because they have already been mapped, we don't need to do this. But you see product ID, product name, quantity per unit is an integer, unit price is a float, and so on. So if I have a new file, I can basically just say, select the file here, and then add the properties from the file, and then they are mapped to my entity. Right. The other thing that's important is down here, as you can see, the ID mapping. So we need to know kind of what's the ID of our entity, and so that we can connect them as well. Right. So which is interesting because, as you can see in the CSV, we have the category ID here as an information, but we don't have the category ID in our mapping here, right? Because we don't need to store it, as we said before, because it's kind of part of this inherent relationship. We have a second node called category here, which we mapped from our category CSV, which have category ID, category name, and description. So if I go here somewhere, it has categories, and you see category ID, category name, description. And we skip the picture because that's just a large byte string, basically. And here we pick category ID as our ID. And then the interesting part happens where we add this part of relationship, right? So what it does is actually really interesting because it knows that in the product file there's already the category ID, and in categories there's already the ID. We can basically use that to map this. So it basically uses this products file that we just looked at and say, hey, can't we map the product ID to our category ID, and this is our relationship. So if I could just delete this relationship here, we can draw it out again. So we just pull it out again, and I have to put in the name. So you can come along or leave it unchanged. So I just do part off. I select our products file. And then we basically say we create this relationship from the product ID to our category ID, and then it becomes solid, and this is basically how we can map a relationship. And if we wanted to store additional information on this relationship, and the file had additional information, so for instance, imagine in the file we also would have, I don't know how many variants of this product are in this category or something like that, right? Then we could add this as additional relationship properties as well, right? So that's another thing that we can pull from our data from the CSVs to add this to the relationships themselves, right? And so now you can basically look at the different entities that we have here: supplier with all the information, order with all the order information as such. We have the customer information, which is pretty detailed. And here, actually, if you go back to the question that we just had about what's basically a relationship, what should be into a node, what should become an attribute on a certain node. It really depends on the use case, right? So, for instance, in this model, the address information of the customer is not pulled out, but you could make the case and say, hey, actually, these addresses should be reused across customers, or we want to basically use this as an additional discriminator, and we want to pull this out as additional information. Then I would say, okay, if this really makes sense for use case to pull out the addresses, then please do. But if you basically just store them and retrieve them, and you don't really do anything with them on the graph side, on the graph pattern side, so you can, for instance, you don't say something like, oh, actually, we want to correlate customers by which place they come from, something like that, then I would probably keep this just as attributes in here, right? Also, if you have very attributes that are very little discriminating, so something like country, right? So, I mean, in our data set, we might have 10 million customers from Germany or 50 million from the US or something like that. Then country just becomes a node that almost everyone is connected to, and then it doesn't add really much information as a structural node in the database. So I would just leave country, for instance, as an attribute on address or on customer here as such. Right? So that's for the modeling question as such. And then we can see, we can also have self-relationships on the meta graph. So basically the employee has a relationship to another employee, which is basically reports to. So it's basically, if you click on the reports to relationship here, we see that it basically maps from the employee ID to the reports to column. And if you look at employees CSV, this one here, we see we have our employee ID over here. And then if we scroll down here, we have reports to. Let me scroll up here, the reports to. So which is the manager, basically, right? The manager's ID. So we basically map this employee to the employee that they report to, so their manager as such. In principle, you could also add a second employee node to this model and just connect it directly. Then you could map the second employee node as well to the file. But the self-relationship actually is nicely representing how this looks like. And then things like territory and region. So this is kind of one of these, which we could have left with the employee as such, only if it really makes sense to pull them out if they add something to the use case as such. Cool. You can also fold in these sidebars as well, so that you have a little bit more room to work with. So, for instance, the files sidebar here. So, if you want to, you can also create multiple relationships between two things. So, for instance, if a shipper not only ships in order but also returns in order, then you can basically add a second relationship that then, for instance, would say returns, and I can switch the relationship direction and it goes in the other way around. So, for instance, if I have information like this, I can also map this as well. So you can have as many relationships between two nodes or relationship types and also relationships between two nodes as you want. And you can also, if you select something and or multiple things, then you can also press delete, or you can move them together or things like that, right? So there's lots of interactions possible in here. Cool. Now that we mapped our data to our graph model, we are basically ready to go to import the data into the database. Are there any questions so far for the mapping or the preparation of the graph model as such? Alex, did you get anything else?
No question in particular on this. There was one question on the amount of CSV files you can use with data importer. If there is a limitation, if they have a lot, would you say at what point would other tools make more sense if you have a lot of, a big number of files, or lots of rows in there?
Yeah, that's a good question. So data importer is definitely meant to be a getting started tool, right? So you can import probably around like 1 million entities with data importer. It takes a few minutes to import it, but it works. But it all runs in your browser, so there's no server-side component for that. So it's basically what your browser can support. And it's also not a tool that basically allows you to run it in the background or something like that, right? So it's like it runs in your browser. It uses multi-thread background workers to actually execute it. But I would say, a few 100,000 to 1 million rows in total, a number of files, whatever you can manage. So this is already like 10 or 15 or so. So I think if you go way beyond 40 files or something like that, then it becomes a little bit harder to manage. It still works because you can fold them together, right? So and I also really like that it shows you which properties you have mapped, so you don't need to remember that, but it shows you what has been mapped, and then you can just fold it away if you're done basically with the file, and then it's just a single line in here, right? You can also remove files and replace them with some other files as well. And what's actually really cool in Data Importer, after you've done the modeling and the mapping, you can basically download all your CSVs together with the model and the mapping together as one big zip file. This is also what basically this button uses. It's basically one zip file that has the CSVs and the mapping in there. And then you can hand it to a colleague or to someone else, and they can load the model with data basically, and then they can continue where you basically left off. Or for yourself, if you just want to store it for safety and want to continue later. It also stores the model and the mapping in local storage, but the files are gone. So you will need to re-add the files if you come back later and you close the tab, basically, and you come back as such. But I oftentimes just download the model with data, and then we have a zip file. So for instance, in our Monday sessions, I often do this, and then we put it into the GitHub repository for people to take in. And with clear all, you would clear all the files and all the mappings and everything as well.
Yeah.
Cool. We have 2 minutes. I think we can look at the preview, and then we can have a quick bio break, or whoever needs to grab a cup of coffee or something like that.
Yeah.
So if I click on preview, that's actually a recent feature, which is quite nice, because sometimes you mess something up with the model or the mapping as such, right? And before you do the real import, you actually want to see, can I basically preview my data, what it would look like in the graph? So this is actually not going into the graph, because Neo4j has a transactional database. We can basically pretend to import and then roll back the transactions and still get the nice graph visualization out of it. So you can see here, we have different colors of nodes in our visualization. And if you open up the sidebar, we see, so it takes a few lines from each file to create a number of nodes and relationships in the preview. So for instance, if you have like millions of nodes and relationships, it will only create, a few hundred nodes and relationships in the preview. And then you can basically inspect them and say, hey, do all the properties look correct? Are all the relationships in the right order and direction? Is my connection here from, for instance, Tom's Spezialitäten aus Münster? Is this what I expect basically as well? Are the categories right? Is naming, spelling, and so on of stuff? Didn't I mistype one of the label names or something like that? As such, right? So if you click on an individual one, you see the properties of each. You also see what data type it is. So for instance, let's see, not this one, but so freight is a string, but I think the mapping for unit price here, you see that it's mapped as a float, for instance, right? Or the reorder level or stock as an integer, such, or discontinuous as a boolean. Right? And if you just click into nothing, then you see like all the attributes, all the labels and all the relationship types in your graph so far. Right? But this looks good, and so we can use this basically to now run our import. Right. So I click on this, and you see that it starts here running our import. It takes a few seconds for this smaller data set. And so it took 8 seconds in total. And we see like all the individual files. So for each file, it basically does a batch import. So it doesn't import the whole file in one go, but it cuts it into smaller batches, and then each batch is imported individually. So even if your Neo4j instance, like our RDB3 instance, doesn't have so much memory, it still can import even large files with 1 million rows or something like that. Right? And if you click on show Cypher, Cypher is our query language that we'll talk about a little bit later. It shows you actually what did it create as a unique constraint with the ID field, and then what did the input look like. So it basically takes the input records from the CSV and creates a territory node here with this ID, and then sets these additional properties. So perhaps you can look at product, which we'll know a little bit more about. And it also shows you how big the file was, how many rows were imported, how many nodes were created. So for instance, if I run this again, it will not create new nodes. So this will become 0, but it will still set the properties, for instance. And it also reports how many queries did it run in total. So for instance, for our products, it created 77 nodes, and the attributes. So we get the product with the product ID, and then you see all the attributes basically are also set. And for things like integer and float, there's an trim and to integer operation. And for Boolean, we basically do an to lower of the original value and say if this is 1, true, or yes, then it's true. Otherwise, it's null or false. All right. So that's really nice because you then can also copy these Cypher statements. So you can also download this. Actually should be possible to download somewhere, and use it in your own scripts as well. Right. Cool. I would say let's do a quick break if there are any questions. So feel free to grab something to drink. And while we're doing that, in the break, I can show you where you can also find this data offline. So we have all this information also in the GitHub repository. If you go to Neo4j Graph examples /Northwind, there's also like the explanation example things, and also in import, I think I put the zip file for data importer as well, right? So basically here, this is the zip file that I mentioned that I just saved and then stored as well. And on our website, we have also a number of pages that are interesting, like for instance, on our developer pages, we have something like comparing SQL with Cypher, where we also go into things like, what does the same thing in SQL look like in our query language? So these are some additional things, or relation to graph as well. I think that's in Get Started, RDBMS to graph, right? So basically it explains how you would map a join table to a relationship, and what the differences and similarities are between the two as well. Mm-hmm. And there's more on data modeling and so on. Right. So
shall we?
I think.
Yeah.
Should we continue, or what do you think?
Should we do some?
Oh, the other thing that actually we can promote is actually our Monday live stream, Alex. Right. So if you go discover. Alex can also share the link in the chat. So Alex and I run every Monday, or almost every Monday, a stream which alternates in terms of times. Either it's in the afternoon for us or in the morning. So either we cover Europe and Asia Pacific, or Europe and the Americas. And we do live streams. We've done a lot of them already, right? As you can see, and we pick all these fun data sets and see what we can do with them. Kind of how would we model them? How would we import them? Sometimes we use the data importer. Sometimes we load the JSON from APIs and discuss different modeling alternatives, and then kind of visualize them and run a bunch of queries on top of them as well. So which is
and the goal is always that we kind of finish within an hour from table to graph. So it's supposed to show how quickly it can go with more or less any data set you have either available or you pick from an online source.
Yeah, like we pick it from Kaggle or someplace else, right? So we have a lot of different data sets and sources that we pick. Sometimes we also see things submitted by folks. So for instance, if you have a data set that you would love to see us import, then feel free to drop us a line, and we'd love to see your suggestions for data sets. Check this out and see if we already covered you, or if not, what we would want to add.
Yep.
Cool. And with that, I would say let's continue in our journey, because we have still a lot to cover, right? So now we imported our data into our graph. Import also ran out without errors. Sometimes there's an issue. For instance, the import doesn't start when you forgot to map a node, or you didn't assign an ID to a node or so. Then you just go back and fix the issue and then rerun the import. Sometimes there's also an error. For instance, if you exceed the data limitations of your RDB3 instance, or if there was something broken in your CSV file further down or something like that, then you can basically, you see these errors here listed here, and then you can fix them and rerun the import as well. You can always re-add files again, then they will basically just replace the previously added file. Cool. And now we can basically start exploring our graph, right? So I just click on Start Exploring. This will open our Explore tab in Workspace, and we create something called a perspective here. So the Explore app is actually something that's built for not so much for developers, but for more data analysts or fraud inspectors or journalists and people like that. So we actually can also continue our guide here, and this is kind of the explore bit. So we clicked on create perspective, and it basically inspects the data from the graph, and we see now like all the things that we had added before. And if I click on this, it opens up an empty scene here, and we see all the different entities in our legend here on the right side. We can also fold in that legend if we want to have more space. But what we want to do is basically click on this in the search bar here, and the first one is actually quite nice because it says show me a graph, because that's what we want to see, right? So we had all the CSV files, all the tables. We looked at the meta model as a graph, but what we actually want to see is a real graph, right, without data, right? So, and if I click on, if I hit enter after selecting show me a graph, we get this. So we have here, let me pull this out again. So this is in a region, for instance. This is a territory. This is a supplier which supplies two products. We can right click this and say these products, I want to see which orders this product was part of, for instance. And then for instance, for this order, we can expand to the customer, for instance, right? So this is kind of the customer as well. We can also, if you have multiple orders selected, so if I can just click Control or Command on a Mac, I can also multi-select things and then say expand all customers, then it will pull all the customers for these orders out. Yeah. So these are kind of some interactions that we can do. We can also change our styling. So for instance, if you want to say, okay, for each of our orders, which are here, we also want to add, for instance, not just the shipper name, which is currently it, but we want to actually say it was shipped, the shipment city. So where did it go? And I want to see, let's see, where is it? Let's say the order date or something like that, right? Then you can now see basically these are now order date 1997, and it's going to Seattle as such. You can also change, of course, colors and change add icons. So for instance, if I want to have something like an order, like a shopping basket or something like that, like a shopping basket, which one? This one here, for instance. Oops. Yeah, like this shopping basket, then I basically immediately see what is my order. I can also change the size of things. So for instance, if I want to say, I want to, for instance, have more expensive products being larger, I can say I go to my product and say I want to do a rule-based style based on unit price, for instance, and then let me pull this out a little bit here. Product, rule-based, unit price, and then I see a histogram here, and then I want to apply the size as a range, actually. I want to have a range for size. And then I want to say, okay, the small one should be really tiny and the large one should be really large. And if I click apply, then it changes basically the sizes of our products based on their price. So for instance, this Mishi costs 97, so it's larger than our Matthias herrings that are for 25. Right? So you can also use information from your data or from the graph to style and configure things as well. Right? You can also do fun graph operations. So for instance, if I select 2 nodes here, I can right-click and say I want to have the shortest path between these nodes. Or actually, I can say I want to dismiss all the other nodes. Let's do this first. And then I can say I want to find the shortest path between them. And this would basically find me. The shortest path is here via the seafood category, right? So we have those in the seafood category. And then I could expand from here. For instance, I could also say what else is in the seafood category, right? So I would expand the part of relationship and then get all the other products in the seafood category as well. And then from here, I could, for instance, go to the orders or the customers and so on. There's many more things that I can do. I can, slice and dice things as well. I can say, for instance, I want to slice my products by unit price. I'm actually not sure why it's showing like this. I can have different layouts. So for instance, if I look at these category things, I can have something like a hierarchical layout, and then it looks like this instead of the four-space layout, and many other things. So Bloom is or Explore is really powerful. If I double click on something, I also get these kind of cards here that show me the data details. I can edit my data here. For instance, I can change it from true to false or something like that. I can change the IDs or product names or things like that. I can also add more labels. I can look at the neighbors of my node as in a tabular representation, filter them by label as well. I can also look at the relationships between nodes in this tabular style, and also look at them basically filtered too. And I can also edit these relationships, and I can also create new relationships. So for instance, if I select two nodes, I can create a new relationship between them as well. Cool. That's it for Explore. There's much more that you can do here. We can have saved Cypher queries that then basically do more complex operations. We can have actions that do something with selected nodes or relationships as well. So we are only scratching the surface here. It's a really powerful tool, but it's targeted more at end users that are not developers. So as a developer, you would probably use this to create a nice looking graph visualization that you want to add to one of your slides or documentation. Or you want to prepare stuff for your business users as well, right? So this is like more the business user tool as such. Cool. And from here, we would go to query, which is kind of the meaty bit for all of you here. So query is actually, so if you follow our guide, query is the next one, which is where you would write your queries for your data, right? So far we only looked at no code things. Now code comes into play, and I want to teach you a little bit of our query language, and we're doing this interactively, but all this information is also in the in the slides as well. So from that perspective, you can also follow along later. Cool. So we can pretty quickly start by clicking on this database icon, which is kind of weird because it's kind of the cylinders that no one remembers. The databases were stored on magnetic spindles and cylinders a long time ago, similar to the floppy disk icon, because no one remembers what a floppy disk looked like. I might have one lying around somewhere here. My first floppy disks were 8-inch floppy disks, like LP size ones, many 100 years ago. So speaking of products, so what we can do here is basically we can click on this product label here, and then it will generate a query for us that pulls our products. I close this again so we have a little bit more space, and I also make the guide smaller as well. Actually, I can actually close it, I think. So this is our first little graph query that we can run. And basically, the Neo4j graph query language, or let me actually go to the slides real quick. So I have all this information that we just did in the slides as well. And if you want to go to query, that's basically where we are now. So let's talk about this graph query language a little bit. So as you've seen, we've done a really fine job, I think, building a database with transaction system or all the other things. We built the visualization tools as well. And when we built Neo4j in the beginning, we were also thinking about, do we actually want to use SQL for querying these graphs, or do we want to use something else? And because if you use one of these more complex domains and have more complex queries, you basically, if you write this all in SQL, you have join on join on join on join on join, and it doesn't look pretty anymore, and you don't see the forest for the joins anymore. And so that's why we built something else we call Cypher. or we call Cypher, which is actually predecessor to the future GQL language, which is currently in ISO standards committee processes. So basically, in a year's time, you will have a parallel language to SQL called GQL that has many of the features that Cypher has today. So looking forward to that. So Cypher is a query language similar to SQL. It's declarative, it's expressive, and it has pattern matching at its core. What does pattern matching mean? We use ASCII art to write our queries, which is quite nice. So quick in between, there's a ref card for Cypher. It looks now a little bit different. So I really like the colored one. But if you go now to definitely Neo4j ref card, you see the current one, which looks a little bit different. As such, I can also show it later. So basically, what we do in Cypher with ASCII art is basically we represent what we had as drawing on our screen for the graph model. Perhaps you can go back to the graph model here. In our graph model, these nodes and relationships we actually represent with ASCII art. So that means we take the round nodes and put basically parentheses around them, so to represent the circle. And we use arrows, ASCII art arrows, to represent the relationship arrows as well. So basically, the simplest query or the simplest representation is just a pair of parentheses, which is a node. And then I can do dash dash greater than, and that turns into an arrow to another node. So that's our minimal graph pattern. A node is connected to another node, right? And that's how we can specify our data that we're looking for, right? Patterns can be used to find data, to create data, to check against data, and so on. And if you have more information about our nodes and relationships, we just add this as additional information within the parentheses. So for instance, if I put product here and for instance, category here, I have basically the pattern of a product being connected to a category. Right? And if I, for instance, have more information about the relationship, then I can put in square brackets here and say part of, and then this is my graph pattern for product is part of a category. Basically the same as we had here in our import. Right? So if I, let's see if I get this zoomed in here a little bit. Oh, did this work actually? I don't know. There's a cool way of zooming, but I might not somehow. There we go. Right. So this basically product part of is basically the same as you can see now in query being expressed here in the query editor. Right. So and this is what we use then to find data, to update data, to create data, and so on. Okay. So basically what we got here is basically our pattern, which is our product pattern, right? So we find our product in the graph, and to find something, we just prepend this with match. And we have to give it a variable name, P or N, also whatever makes sense. Let's call it P. And we say return P. We can remove the limit. So this is kind of the minimal query that you can write, right? So basically find something and return it. And as long as you return nodes and relationships, by default, they will be rendered as a graph visualization here. So if I can zoom in here, you see our entities, and similar to the preview in the import tool, we can also look at the different products and their attributes here. If you click on in the empty space, then it shows us how many products we have. You can zoom in. We can go into full screen mode as well. If you only want to work in this view, we can always go back and edit our query in here. So for instance, if you want to look at everything that has something with, let's say, where p.product name. So we can also type completed actually. Why does it not type complete? Let me just back to this view. Yeah. Product name, for instance, contains. Here we have Sir Rodney's, right? So if you say contains Sir, then we should have syrup, Rodney scoop or scones, and marmalade, right? So, and then we can basically write expressions like this. So this is still our pattern, and we can basically express things as predicates here. We also have an inline syntax for those, but that only does equality. So for instance, if I want to put in a product name here, I really need to spell it out. So I need to basically copy my Sir Ronald scones here and copied also the name. So if I do it like this, then I get basically one result back, because then it's equality comparison. So that's an inline syntax. But for seeing the pattern, it's actually nicer to have them the predicates outside, and then we could do everything, right? So we can also say where unit price is greater than 20, for instance, right? So then we get all the products that have unit price of greater than 20 here returned. And so that's how we can request or query for entities. We can also say we want to have actually units in stock, p dot, let's see, what else do we have? And p dot discontinued. And if we return it like this, we get a table back, right? So then we can basically look at the table, copy stuff from here, and so on, right? So then we don't get a graph back, so we don't get nodes back, but we get a table back, and then we can also do other things like aggregation and so on. So I think so. Adam will go into more detail on things like aggregation and more complex queries. I want to look into expanding our patterns a little bit, right? So if we go back to our products here, so you see we also get a table actually. So you can see we have the graph here, but we also get a table when we return nodes. But by default, it will go to the graph view as well, right? So, and if we continue our pattern here, so if we say, for instance, our product is part of a category, then we can return P and C together, right? So we return the product and the category as such, and then we get product nodes and category nodes. But why don't we get our relationship? Because we didn't give it a variable and didn't return it. So we can also put in our relationship here, return it, and then we see all the categories with their products that have a unit price of more than 20, right? So for all the products that have not a unit price of greater 20, they are not returned. So we basically filter by a predicate, and then this is used to expand the pattern here. So for instance, what you can say now, for instance, is part of, right? So if you want to be really clear, so for instance, imagine there were multiple relationships between product and category. So for instance, there would be something like accessories or something like that, right? So what would be an accessory category to a product or something like that? Then we could have another relationship from product and category, and then these would also show up here if you don't specify the part of. But now that we have specified the part of, we have those relationships here. All right. So, and from here we can expand this further. So for instance, I said this will only show us or let's make this more expensive. So let's say we have unit prices of greater than 90, right? So we have only like 3 products and 2 categories in our database that have more than 90 US dollars or whatever as unit price. But actually we want to see what else is in those categories of these really expensive products, right? So what we can do now is the following. We can continue from this category to continue to spell out these relationships. So for instance, if I say, what else is part of this category? So we have a product 2, P2, and we also want to return this product 2, right? So I can basically say we have a relationship 2 here and a P2, and then if I also return R2 and P2, then we should also see all the other products, right? So we see the P products, the expensive ones, and the P2 products, which are the other products in those categories where we have an expensive one. So here we had this one was our expensive product, and all the category and all the other products are coming from this query as well, right? And if I look at the table view, I actually see them as individual columns returned as well. And the graph visualization basically pulls them together into one visualization as such. Cool. And because it's kind of annoying if I just want to see the graph and I have to spell out all the other stuff, I can also leave this off and then just assign the whole pattern to a path and then just return the path as such. So we can basically don't need to spell all the other things out. So we can leave off this R and this C, because the only thing that we need to basically name here is the product for the unit price as such, right? And so this gives us the same information as well. Cool. In our graph visualization, we can also, for instance, double click here and then basically see which orders was this product in, and then click on the order, get to the customers and the other products that are in this order. So this is a pretty large order with a lot of products. We have our shipper here, the blue one. This one is the customer, and this one is the employee who sold this, right? So and if I click on the employee, then it shows me all the stuff that they sold, and then we can basically go back and then so they sold all these things on the screen as well. So you can also interact a little bit on with this graph as well. You can also style it. So if you click on the label here in the sidebar, you can pick a different color, for instance, or different size, or a different value that's shown, right? Instead of company name, it could also show the ship ID or the phone number here as well. Right? And if I have all the, labels and relationship types here, I can also basically do the styling from here as well. One thing that's interesting that I forgot to mention actually is the following. You might remember that in our relational model, we had order details as a table, right? So which is kind of the line items as such. What we did in the graph model here is actually we put the order details on the relationship between product and order, which is again one of these modeling questions, right? So if it's really important to have the line items and we want to connect more stuff to the line items, we would probably pull them out as nodes. So if they are an important part of our domain, but if they're just inherent, something that we want to capture, then we can basically put the line item information on the relationship as well. So the orders relationship actually has all the line item information between order and product, right? So like quantity, discount, and unit price as such, right? And this is actually something that we can do quickly. So imagine we wanted to compute the total quantity for an order, right? So then this is actually something where we want to express the pattern between product and order, and then apply the count and the unit price as such. So if you wanted to do this, let me have a look at the time. Then we can basically spell out, we have our order, which orders a product, and this is our relationship, and then we can basically return product.unit price, which is also stored on the relationship. So we would probably use the one from the order itself, because if over time the unit price of the product changes, probably don't want to use them from the product, but from the relationship. Unit price times quantity, ordered quantity times 1 minus ordered discount. Right, so discount is a percentage, so it's 20% discount, I guess. And so this gives us for all the orders limit 5, and this gives us for all the orders the value per order line. And then if you want to sum this up, we can just sum this up, and then we have the for each order dot order ID or something like that. It doesn't show me suggestions. Order ID as total. And then we get basically for each order our total. So this is just a sneak. So Adam goes into much more detail next week. Cool. That's almost all about querying. One thing that I quickly want to show.
Yeah, interesting question from Arnaud on the chat. When you click on a node, can you maybe go back to showing a few ones, and then you if you click on one node, you have a couple of options. If you could explain what these are when you.
Yeah, I can do that. So these options are basically the following. So one is usually you see when I move my node here, then all the other ones are moving as well. But if I drag one node to a certain position once, then it gets stuck there, right? So one option, the unlock, is basically just I unsnap it again. So it basically should go back. Why is it not going back? It should actually go back, actually. Now it went back. Right. So that's the unlock. This relationship icon is basically expand. So it basically takes all the relationships of the nodes and shows them. And if I click it again, it takes the last ones away again. So if I just quickly want to check what is in this node, then I double click or click on this. And then if I want it to go away, then I click again. And the I with the minus sign, it basically removes the node. So if I remove this node goes away. If I remove this, then this node goes away. And so on. Or for instance, here, I can also remove this one as well. These are the three options that are currently in here. Cool. Thank you for the question. The other thing that I quickly wanted to show is how to create a piece of data. So there's two options in Cypher. One is called create, like create data, and the other one is called merge. For beginners, I usually recommend merge because then you can run it time and again, and you don't create additional data, but you would only create, the same information again. So, for instance, if I want to create a new product where the product name is, let's say, cheese, and I return this product, then it creates my cheese product. So you see that it doesn't have any other property, so it's not part of what we imported, but it's kind of newly created. And if I run this time and again, it will just stay one cheese, right? If I had chosen create instead of merge here, it would have created multiple cheeses as such, which my pet rats would be happy about, but probably not your database. And then the same way you can also create relationships. So for instance, I can now find our dairy products category name, dairy products. So I can return P and C. Oops. Okay. So here's our dairy product and our cheese, and currently cheese is not connected to anything, right? So because we just created it, but now we can basically say, I create a new relationship between this product as part of this category. So you see, we use the same patterns again to create data as well. And if I run this, it will basically, I can call this new relationship R, then it will basically show our relationship. And I can run this time and again, and now this data is in my database. But if I rerun this, it will not create new relationships because this cheese does already exist and the relationship does also already exist. So it will just basically get me the information from the database if it wasn't there before. But that's just a quick sneak into like how to create data and connect information if you want to do it with the query language as such. Right. Cool. Now I have two more things that I want to show you. One is really quick. This query language you can now use not just in the UI, of course, but with any programming language. If you remember, we had these examples here where you basically can, in Python, JavaScript, Java, .NET, and Go, have examples on how to use Neo4j drivers to create data, to query data as well, and so on, right? So this is Python code. Probably not the nicest Python code, JavaScript code, Java code, Go and .NET code for the official drivers. And then there's also support for Spring Boot or Spring Data Neo4j actually, and GraphQL. And GraphQL is actually what I want to look at with you, because there's a really nice tool from our GraphQL team called GraphQL Toolbox. And this can basically automate much of this stuff for us. So first I need to connect to my new instance, because I tried this on an old instance. So we need our password and our Neo4j UI. So basically what you do is you go to GraphQL, sorry, GraphQL-toolbox.neo4j.io. Alex, if you can paste this as well into the comment.
Yep.
And then you provide your username,
yep,
password, and connection UI. Click connect. And oops, sorry. That's not what I wanted to do. Press the wrong button. So let's do this again. And this is the wrong one. It's the right one here. Connection already has data. Would you like to inspect? Yeah. So what I want to do is the following. So if I connect for the first time, what I get is actually this is empty, or I get something default. And then there's this wonderful introspect button here, which basically takes the data from our database and turns it into GraphQL type definitions. Which reminds me, that I wanted to talk about the GraphQL type definition. So if you have not heard about GraphQL, GraphQL is an API query language. It's not in Graph query language as such, but it works really nicely with graph databases. So it basically, you describe your data with so-called type definition, which is basically a schema, and then you can run queries against it. And so Neo4j has a library called Neo4j GraphQL library, I think. And that allows you to take a GraphQL query and turn it into a Cypher query behind the scenes. So if you're not ready to learn Cypher, but you already are familiar with GraphQL, this gives you a really quick way of getting started with your graph database as such. So if I go back to our GraphQL type definition tab here, and this is what you can actually write them yourself. So I can say type product, and then say product name colon string, and then I can say product, it's uppercases, product ID, and so on, right? So I can do it manually, but I can also just let the library do my work and click on introspect, and then it basically goes to the database, similar to like how Explore did before. Goes to the database, extracts all the information, and then we have all this information here. Right? So we have our category with category ID, category name, description, customer, employee, and somewhere also we have product with product ID, product name, discontinued, unit price, and so on. And what's interesting here, there's also a part that represents relationships, right? So we have a category, and the products that are part of this this category are represented with this field, which basically gives us back a list of products. This square brackets here is a list of products. And then it says basically this is represented by this relationship type pointing to the category. Like that's why direction in. So if I want to, I can rename this. I can just say this is just products, for instance, right? And then, so I can do it for the different fields. I can also remove fields, and there are lots of additional options that you can append here to each of those. But what's the interesting thing is if you click on build a schema, it will actually give us the ability to query this data, right? So for instance, if I just say something like products and say product name, this will fetch all the products from our database, right? So it basically says this is a tree query, give me the products with this product name. And if I run this, then I get like all the products names, right? If I want to do something like unit price, that's also really nice about GraphQL, that the developer experience is really nice, right? So you can see basically units in stock, and so on. But what's actually more interesting is basically see how the relationships are represented, right? So we have basically our category relationship is part of categories, which gives us as a category back. And then for the category, we want to have the category name, for instance. Here. So if I run this, then it basically gives us for each product, the product name, the unit price, and the category name that this category product is in. And so I can continue now from this category. I can also go what other products are in this category, and so on. Right. What else I can do is I can basically provide things like options here, let's say limit 5, then or say limit 3, then it only fetches 3 products here, right? Or I can also say I want to have products that only start with CH. Then I can basically say where product name starts with one and then say CH. And options, I only want to have 3 of them. I can actually remove the options here as well. And if I run this, then I get only the stuff that starts with CH. So chai, chang, chef Anton, kajung, seasoning, chartreuse word, chocolate, and cheese. See, our cheese is also here. And it doesn't have a unit price because we didn't create a unit price back then. And then other things that you can do here is also I can basically do also aggregations. For instance, I can say in how many orders is this product, for instance. But then it will do aggregations behind the scenes, and I see how many orders this is into. And so GraphQL is really popular in the JavaScript and TypeScript ecosystem, but also in general for API development. And it lends itself really nicely to UI development because you can basically imagine that these queries are representing one UI screen, and then you fetch exactly the data that you want to do. And because we added in the type definitions, we checked the debug thing, we actually even see the Cypher statement that is built by this GraphQL query, right? So which is quite nice as well as an additional bonus. And then of course I could take this CH thing here and turn it into a parameter. So for instance, if I want to say this is my name and I say query name is string, color name is string, I can put in my CH here. And then it would basically run the same query, but I externalized the values as such, right? So then I don't need to hard code it into the query. It's passed in. And this GraphQL library basically allows you to take these type definitions that we have over here, and then basically add them to the library. I think the docs are linked here in the sidebar for all the things, and it basically has all the information on how to set up a project, how to combine it with Apollo server, and how to build your GraphQL library API, that is backed by Neo4j. As a really quick teaser, so we went basically all the way from where's it? From model all the way to build as such, right? So we modeled, we imported, we explored, we queried, and now we built an API as well at the end. And with that, I come to the end. What else is there? So Neo4j, of course, doesn't sit in isolation. We have a lot of connectors for Kafka, Spark, and other tools. We have JBC connectors. We have I already showed the drivers as well. If you come more from a data science background and you're interested in things like, graph clustering, graph neural networks, things like centralities and node classification, link predictions, and things like that, that's covered by the Graph Data Science library. And then I quickly showed GraphQL. I mentioned Spring Data Neo4j. There's also a Neo4j OGM that doesn't require Spring. We have RDF integration with Neo-Semantics, APOC as a utility library, dashboard tools. We have Neo4j migrations for schema migrations or data migrations as well, liquid-based integration as well, and many other projects around this. How can you continue your journey? As Alex already mentioned in the beginning, we run the next few Wednesdays, we run workshops. Basically, next week, Adam will talk about intermediate Cypher, so basically going a little bit deeper into Cypher. Then my colleague will build a routing engine, so looking more at Neo4j spatial routing, OpenStreetMap import, visualizations of that as well. Bloom can also visualize geospatial data as of the latest version. And then in April, my colleague Garrett will talk about Spring Data Neo4j, which is an object graph mapper for Java. And that's also how I started to work on Neo4j, was basically the first incubation of Spring Data Neo4j. That was 13 years ago as such. So if you want to register for these workshops, Alex also shared a link and probably also put it into chat. And with that, I think we're open for questions. So if you want to learn more, I already showed Neo4j Graph Academy. We have a lot of videos on YouTube, both our live streams that we do on Mondays, but also Alex does more live streams across every week. So we must have hundreds now, meanwhile. And we have a Discord and a discourse forum as well. So if you have more questions, feel free to join us on the chat or on the forums as such. So, and with that, I'm open if you have more questions to cover.
Yeah.
Or if you want me to go into any detail of the things that I went over too quickly.
Cool. Yeah, I think let's give it a second or two, so people can ask another round of questions. There was one that I found was maybe interesting. So we went today in this intro session. We went into the world of Aura, Graph Database as a Service. What other options do you have when you want to work with Neo4j, or when you want to deploy Neo4j? Basically, is that something?
That's a great question.
We can talk about quickly.
So on the Neo4j docs page, there is something called the operations manual. And the operations manual actually goes over this, right? So we have, of course, you can install it on your desktop. So we have Neo4j Desktop, which is an application that allows you to run Neo4j locally. There are also like systems integration installations for Linux servers. But usually today you would either use Docker or Kubernetes to deploy it to the cloud. Or besides Aura, we also have marketplace images for AWS, GCP, and Azure as well. So you can basically just go to the marketplaces for the cloud services as well to run them there. We have an official Docker image as well. So it's basically on hub.docker.com Neo4j. That's the official image that's maintained by us and published by Docker then, so which you can run really easily as well. And we have also Helm charts for Kubernetes as well that you can use to deploy larger, more complex setups of Neo4j. And Neo4j runs both a single instance, like RDB3 is a single instance, but the usual production deployment of Neo4j is a cluster deployment for high availability and failover. And there's also sharded deployment with Neo4j composite databases, where you basically then can shard your data across multiple instances as well, which is also described in the operations manual as well. And in the docs, you have also much more information on Cypher, on the different tools, on Aura, on graph data science, on the different drivers as well, connectors that I mentioned. So Neo4j Comp Docs is definitely also a worthwhile source to look at. And here's also the Cypher cheat sheet linked, which now looks a little bit less colorful, but still very detailed as such. I hope we can get the colors back at some point. It would be nice. Yep. So that's kind of deployment options for Neo4j
Yeah.
I don't think that I forgot anything.
No, I think that's great. I posted a link into the chat as well, so you can see there is more outside the world of Aura. No matter what you want to do, I think you should be covered. The recording will be shared with you. If you registered for this webinar, we will share it with you via email. So I'll send this out probably tomorrow as together with the slides, and then you can find everything. What we discussed today, and then you can follow along afterwards if maybe it was a bit too quick, or you want to repeat something again and you want to see how it was done. You get that all in your hands this week, and then you should be able to be good to go. And like Michael said, there are great places where you can continue your journey. So it either is the Graph Academy, where you can learn on your own. It could be hopefully next week on Wednesday again, when we talk about a little bit more about Cypher. And definitely a good place to go is the community on the forum or on Discord, where we are available around the clock almost. And we, I mean this not Neo4j only, I mean we specifically
community.
The whole of the community, graphistas from around the world who go there and
so we have
talk.
A lot of people asking questions, answering questions on the community as such. One thing I saw that Ashwa had a question on Jupyter Notebooks. So in the docs for the Neo4j Graph Data Science client, there's a bunch of tutorials, and here's a good example on if you click open in Colab, it shows you basically the code for connecting to Neo4j with the Graph Data Science client, which allows you to run Graph Data Science operations, but also just Cypher as such as well. So that's something that might give you a quick example for those as well.
Yeah, that's a good point. That's something we didn't cover in this training series. We don't go much about in this with data science. So maybe at another point. There is a previous recording from last year where we go in. Let me quickly find the YouTube playlist, so you can check that out for previous hands-on workshops. And there we had definitely graph data science sessions in there for you to check out. So the link is a little weird as our YouTube playlists, but you will find everything in there with our hands-on session, as well as there is a Ask Data Scientists new series from our colleagues Alexander and Alison, who give in short little couple of minutes sessions where they talk about some algorithms, general working with data as a graph data science, or as a data scientist working as a data scientist with graphs, with graph data, and all of that. So that's interesting. So I'm sure there is something around, and maybe in the next training series that will come in the second half of this year, we will include a data science session, hopefully.
Super. Thank you so much. And I think with that, we can conclude. Your database, by the way, your Aura database will stay online, so you can come back later and continue to use it. If you want to use it with other data sets, you can also load data sets here as well. So you can just click and pick one of the other data sets that are available. Or, of course, you can delete it as well, or reset it to blank as well if you want to clean it out or start over. Or you can just delete it and create a new one as well. But the Aura database, ORDB free database, will continue to exist. And if you don't use it for a few days, then it will be paused, but you can then resume it within 5 minutes as well.
There will then a button be visible where you can just click on resume, and then it goes back on. So
exactly.
You don't,
like here, for instance,
exactly,
there's a play
this
button, then
play arrow. Yeah.
Exactly.
And it stays with you forever.
Yeah.
As long as you like, you can work with it and enjoy that. Yeah, I think that's a good finish. Hopefully we'll see you around next Wednesday. I will be just to let you know, on Tuesday evening, 5 p.m. Central European time, I'm hosting an interesting Neo4j live stream on YouTube or Twitch or LinkedIn, together with Friedrich Lindenberg from Open Sanctions.
Oh yeah, Friedrich is cool.
Where we talk about open sanctions against people, against organizations, against assets, and they have this this tracking or this not tracking, yeah, but this tracking
large data
database, large database, where they fulfill the follow up on sanctioned items. So that should be fun and interesting.
Yeah.
So that's happening next Tuesday on the 21st.
Exactly. So if you go to the Neo4j events page, you can basically filter by what you want to see. So for instance, if you want to see live streams and trainings, then you basically just select these two here, and then you see, so this is today, then open sanctions, then is an immediate Cypher, and then we continue basically from there. Right. So, and you can basically go and see or register for all these sessions as well. So that's neo4j.com/events.
Exactly. And yeah, with that, again, thank you very much, Michael, for the great presentation, the demo, and the training. Obviously, hands-on stuff is always good. I hope I see some hearts. I see some love in the emoji reaction thing. So I think that's great. And
happy
yeah, with that, I wish you all a great rest of your days, rest of the week.
Thanks for joining us, and looking forward to see you again.
Thank you for asking your question, and thank you to Elaine and Will for relentlessly answering the questions in chat. So that was super good. I hope that was beneficial to everybody as well. Yeah. With that, I hope to see you next time round. This same place, different time, and yeah. With that, I wish you all
take care, everyone.
Take care, everybody, and goodbye.
Bye-bye.